For the third one, it says show that 2 raised to power n is greater than n raised to power 2 for all integers n greater than 4. This is for the induction on inequalities. So, solution. We are still going to follow all steps followed at the previous ones. We are to make n equal to, since now n is not all positive integers, n is greater than 4. All integers greater than 4. All integers greater than 4 are 5, 6, 7, and so on. So the first integer greater than 4 should be 5. So make n 5, and we should test that 2 raised to power 5 is greater than 5 raised to power 2. So we should test if this is correct. So this implies that 2 raised to power 5 we know is 32, and that is obviously greater than 25, right? So this is actually correct. This is correct. This is true for n equals 5. Following the second step for induction, which is called the induction hypothesis, we make n equals to k. So if n is k, then we can write this expression as 2 raised to power k is greater than k raised to power 2. Now for the third case, which is the most important case, where we are to prove that n, when n is equals to k plus 1, this situation of the question also holds for k greater than 4. Since n is greater than 4 here, and now we make n equals to k, then k must be greater than 4, right? So now n is k plus 1. So if n is k plus 1, this implies that 2 raised to power k plus 1 is greater than k plus 1 all squared. Now, we are to prove. We are to prove that what? We are to prove that the left hand side is greater than the right hand side. So we have to prove that this 2 raised to power k plus 1 is greater than k plus 1 all squared. So now bringing out 2 raised to power k plus 1, we know that 2 raised to power k plus 1 is equal to 2 raised to power k times 2. This is according to indices, where this is 1 and you add the powers. So if that is true, that implies that from this second case, from the induction hypothesis, where 2 raised to power k is greater than k squared, we can say that by multiplying both sides, we have that this therefore is 2 raised to power k times 2 greater than 2k squared by multiplying both sides by 2. Therefore, we can say that 2 raised to power k plus 1, since this can be brought back to this, 2 raised to power k plus 1, is then greater than 2k squared. Now, since we now know that 2 raised to power k plus 1 is greater than 2k squared, now we can actually change 2k squared to be what? This can be written as k squared plus k squared. But I want to write k squared as k times k. You know, when you add two things, it becomes 2 of them. So k squared plus k squared is equal to 2k squared. So this is actually k squared, but I rewrote it as k times k for a reason actually, because we know that k is greater than 4, so we can actually change this one of the k to 4. And if we do so, we get that 2 raised to power k plus 1 then greater than k squared plus 4k. What else can I reduce this as? This can be reduced as k squared plus 2k plus 2k. So now, this is actually equal to this. K squared plus 2k plus 2k is equals to k squared plus 4k. So now what is k? We know that k is greater than 4. Yes, k is greater than 4. So if k should be at this part of the equation, so we can still say that 2 raised to power k plus 1 is greater than k squared plus 2k plus 2 times 8 and 2 times 4. That will give us 8. If you look at what you have been doing closely, you'll notice that I am actually aiming to get this part of the equation, this part of the inequality. This already starts looking like this, but it is not exactly as this, because this, I can write this as, this can be written as k squared plus 2k plus 1, but we have plus 8 here. So now I can write this as this is equal to k squared plus 2k plus 1 plus 7. So now, know that this is 2 raised to the power k plus 1 greater than this. Now, this whole thing can be written as this. Can be written as k plus 1 square plus 7. So now, since we know that 2 raised to the power k plus 1 is greater than k plus 1 all squared plus 7, and we also know by common sense, I will say, we also know by looking at this, we also know that k plus 1 square plus 7 is greater than k plus 1 square. Of course, this is greater than this naturally because of the plus 7 at the left hand side. So if 2 raised to the power k plus 1 is greater than this, and this is greater than this, then I can deduce that 2 raised to the power k plus 1 is then greater than k plus 1 square. So this is what we're asked to prove according to n equals to k plus 1. So it is very true. So this is true for n equals to k plus 1. For n equals to k plus 1. So this is proven.